Earlier this week, I wanted to take a selfie with a multispectral camera and see if I could align the images enough to get a good output. And I'm not trying to like up my social media game or anything. Basically, the reason I did it was historically, MicaSense and other multispectral camera companies that have multiple imagers and lenses, they kind of have this stance that if you're going to image something, it needs to be imaged at a distance so that the parallax error isn't significant enough to cause problems with the output. And I just wanted to see if that was true, given the band alignment script that I was able to generate with Claude. And so I'll just quickly go through this. So here are the selfies of the 5 spectral bands. So those are the raw image outputs from the Red Edge 3 that I was using. And the reason this is relevant for agriculture and any kind of plant analysis work and research is that there might be a possibility for taking the multispectral camera that's primarily used for drone-based mapping and potentially using it for maybe like lab work or greenhouse work, that sort of thing. So I just did a search of imaging at a greenhouse and got all these images. So there's specialized cameras that are designed for like lab-based imaging of individual plants. They look something like this, or there's somebody just using a regular RGB camera, I think. They come in a bunch of different variations. You can do your own research on that. But I just remember when I was working at MicaSense, a lot of people asked me, can I use this in a greenhouse or can I use this not on a drone? And we were always wary to recommend that. And I was always curious about it. Since I had the band alignment program put together already, I thought I would try it. And this is the RGB output, and I was like pretty surprised at how good it did. This was a second try because the first try, it actually was aligning the stuff in the background really well. So like this picture and the closet doors were really well aligned, but my face was not. And so I had to do kind of a tweak of the program with Claude, of course, and I just asked Claude. I was like, "What did I actually do there?" And it says, with a working image, the fringing was still there from the lens separation problem, but rather than accept it, restricted the alignment algorithm to search for matching features only in the center of the frame where the face is. So it optimizes for aligning your face instead of the background. So I guess in short, if you're going to try imaging stuff, not on a drone, just with the camera in hand or on some kind of rig, and you want to use SIFT to align it, you're going to have to do something where if the plant is in the middle of the image, you're going to want to focus the SIFT algorithm to focus on the center of the image so that it actually aligns the plant and not the things in the background. But here are some other kind of funny outputs. So this was a custom composite of near infrared red and green. This was CIR, and then this was NDVI. And there's a wool blanket sitting on the leather chair behind me. You can see that that has high values. My shirt is probably cotton. It has high values. So for some reason, it's picking up the wool as like a kind of like an organic surface that's going to have higher RGB values. My shirt, which is probably cotton, has cotton in it, probably not just cotton, but that also had higher values. So it was kind of fun. It took me maybe an hour or two to figure this out because I already had the program put together. I just had to kind of modify it to work with like a single image close range capture. So I guess the takeaway here is it looks like it probably would be feasible to use this at close range on a plant, but you're probably gonna have to modify SIFT a little bit to get it to work. So that's all for now. Hope you enjoyed the video. Thanks.